Hello and welcome back to Dr. Logic awkwardly does logic in her office. Now that you have kind of the basic idea of what we're going to be doing with our propositional logic proof system, it is time for everybody's favorite, more definitions. So a couple of very straightforward definitions. They're going to look suspiciously like definitions that we have seen before because, face it, logic is just repeating the same sorts of things in many different variants. Luckily for us, there's infinitely many different logics, and so our job as a logician will never be done. But let me bring up my whiteboard so that I can give you the proper definitions for proofs in propositional proof theory. So again, the basic notion of a proof is that it is a finite list, so you got to reach the end at some point, where every entry in the list is a formula, a well-formed formula, and every entry in the list also is annotated or justified by the reason why we are allowed to write it down in our proof. Now, it could be because it's an axiom, or it could be because it's the result of applying a rule. But remember, as I said in my previous video, we aren't going to have any axioms in the system that we're developing for propositional logic. So let me just get that definition down so that we have it. So a proof in propositional logic is a finite list of well-formed formulas where every entry in the list is justified or annotated by one of our proof rules. So if we have a set of assumptions, and one of our rules that I'll introduce you to allows us to make assumptions. This is kind of our way of getting around the fact that we don't have any axioms. We have to start somewhere. So if we have certain assumptions, so if we have, say, assumptions phi 1, phi 2, all the way up to, say, phi n, and from these, we can prove some formula psi, then this is what we write. We write phi 1, phi 2, dot, 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 phi n, single turnstile psi. So you'll recognize this formula. This is the single turnstile, and it is the formula that corresponds to provability in our proof theory. So this is not to be confused with the double turnstile. So if I say, wrote down phi 1, phi 2, dot, 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 phi n, double turnstile psi, this is the semantic notion. So this is a way of saying that psi follows validly from premises phi 1, phi 2, dot, 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 etc. Oops, no, it should be some quotation marks. So, of course, there's ultimately going to be a very intimate link between the relation indicated by the double turnstile, the semantic one, and the one indicated by the single turnstile, the proof theoretic one. We're going to ensure that we develop our proof theory so that these two relations between sets of formulas and individual formulas, that they track each other. But we won't get into that now because we've got just a few more definitions. So if we have assumptions phi 1 to phi n, then we can prove from those assumptions some formula psi, then we can get that. However, if we have zero assumptions whatsoever, so if we have no assumptions and can prove some formula psi, then what we write is just nothing on the left-hand side of the single turnstile, and then psi. And in this case, we call psi a theorem. So that is something that can be proven without any assumptions whatsoever. Now you might be sitting here thinking, but Dr. Logic, we don't have any axioms, and you just told us assumptions are our way to get around the fact that we have no axioms. How can we prove anything that doesn't have any assumptions whatsoever? Well, it's not that we won't make any assumptions, but it's that by the time that we get to our final proof, nothing will depend on the assumptions that we made. We will have discharged all of them. So once I start teaching you the natural deduction system, then a lot of these things will become clear. I will give you many examples of proofs of theorems, so things that don't involve any assumptions, but I'll also give you many examples of things like this, where you're basically saying, well, suppose that we have these premises, and I'm not going to give proof of the premises, we're just going to take this by assumption. Then I can get you this further conclusion. I will even show that there is an intimate relationship between being able to derive something from certain premises and a corresponding theorem that doesn't have any assumptions at all. In fact, this is going to be one of our metalogical results called the deduction theorem. But that is a metalogical theorem, not one of the theorems in propositional logic. It all gets a bit confusing, but we'll separate out the object level from the meta level when it becomes necessary and when we get to it. So you've got a definition of proof, you've got some notions of, kind of assumptions, lack of assumptions, the idea of a theorem, and I've told you that I'm going to make sure that the double turnstile and the single turnstile relation coincide in a very nice and useful fashion. Next video, I get to start teaching you the rules. Take care and see you then. Cheers.